So we're going to be completing GAMSAT Practice Test 1, the first 4 questions. And you will see that it's discussing mice embryos. So just to make sure that you don't fall into one of the other sections. So this is ACER GAMSAT Practice Test number 1, the first 4 questions. And we're going to make sure that everybody can have time to complete it. Please. We're going to make sure that everyone has time to complete the practice questions. There are 4. And so according to the new schedule for the exam, it's 2 minutes per question, as opposed to what ACER says in their eBooks or practice materials. They're still using the same old timing and same old groupings of the number of questions. But if you're practicing the test, you should try to always use the new timing to get used to it. So it's going to be 2 minutes per question. There are 4 questions. You're going to have 8 minutes to complete, and then we're going to discuss the work solution strategies. Okay, can we have a clock, please? And good luck. Okay, so let's start. First of all, I'd like to remind you that you're going to have two A4 sheets of paper for the science section. So there's going to be circumstances where drawing a little image can be very helpful to summarize what's going on. So if this were my scratch paper, I probably wouldn't draw it so large, but I would, put the question number that I'm working on. I would draw something, and I'd also cordon off the paper because you don't want your work on one particular unit to start spilling over to a different unit, and then somehow you misrepresent or misunderstand a number that was in the wrong spot. So cordon off what you're working on. Okay, the other important strategy for you to try, okay, because everyone's different, but the most efficient way to answer the questions is to look at the questions first. So before you start trying to understand everything, just glance at the different questions, and then it's going to make you more alert to certain aspects of the unit. For example, when you just glance at questions 1 to 4, you see that the numbering of the embryos comes up. So that is an issue that we'll have to keep an eye on to make sure that things are in their proper location. And yeah, they're talking about male and feminine features. And also in the last question, genotype is mentioned. So just things to keep in mind once you start going into the unit. So ideally, you glance at the questions, then you go into the unit. By the way, this is very efficient for both the humanities section and the science section. What works best for you is something that you need to try, but this is the most efficient technique. Okay, so when looking at the paragraphs, it starts off by explaining the relationship with the hormonal environment within the uterus and gender development. So nothing that is completely new in terms of understanding, but still, they're giving you that information. Now, in the second paragraph, female embryos located between two males, for example, they're called 2M embryos. And here comes a classic ACER moment. So we are told that a female embryo between two males is a 2M embryo. Now, if you were to try to make this as clear as possible, you might write is an F embryo with 2M in parenthesis or something like that. But they're being called 2M embryos, but they're female. And this is something that you've heard me say multiple times, that ACER loves opposites. So to label something with the letter M, but knowing that that thing is female. And if you label something with the letter F, then that embryo is male. So when you anticipate ACER's does this frequently, then even as you're looking through questions, when you think something seems a little bit too easy, then you'll always have that extra thought to consider, am I doing it exactly the opposite way that I should be doing it? Okay, and then they even have a section that says, in this unit, and just to hyper clarify what was already said in the second paragraph, if it's 2M, 1M, or 0M, they're females. And if it's 2F, 1F, 0F, those are males. So now it's as clear as could be. So they wrote in this unit, but typically ACER puts a note that section. They'll actually put in bold note that in a particular section. And whenever they do that, anytime they write note that, it means that at least one of the questions, the answer will be dependent on what you read in the note that section. So also just keep that in mind. It's one of their little strategies. Okay, so then I just numbered it here. Of course, the ovaries are on top. And then we have the embryos numbered as it is in figure 1 in the diagram that you have. And then it says, suppose embryo 9 is 1M. So Embryo 9 here is 1M. Embryo 7 is 2M. Embryo 7 here is 2M. Embryo 4 is 2F. Here we go, 2F. And embryo 2 is 1F. Okay, so now what we have is a puzzle, and we're going to, you're going to get multiple puzzles on the real exam. They won't look necessarily anything like this, but ACER loves to give these types of puzzles. Now, remember, we've already seen both in the second paragraph and in this unit section that this means an M means it's female. Any M means it's female. Any F means that's male. Okay, so now we know this female, well, this one's easier. This female has 2 males as companions. So that means that this female this has to be male and this has to be male in order to explain why this is 2M. And this one is 1M. Well, there's already 1M here. So that means the other one has to be female. Does anybody have any questions about that? Okay, then over here, we do the same thing. This one is a male with 2 females beside it. So 1 female, 1 female. This one is male with only 1 female beside it. So here's the 1 female. So that means here must be male. And so just by drawing it out, it makes it, more clear. Okay, so then let's look at the first question. Of the following, what suggests strongly for the differential development of the secondary sexual characteristics? Now, it doesn't really matter that you understand primary and secondary sexual characteristics for this unit, because the way everything, all the questions are designed, it could be a little fuzzy in your mind and you'll still get it right. But while we're here, primary sexual characteristics is, for example, are the gonads and external genitalia. Secondary sexual characteristics, breast development, hair growth, bass in the voice, things like that would be a secondary. But the questions are designed so that it makes no difference. However, just to give you a little asterisk about the evolution of the exam, years ago, this same unit, ACER printed, and it had a green cover, and that's why it was called the green booklet. And, some students still sell them on Gumtree or eBay or whatever. But some of the questions have changed. And for this particular unit, 2 of the questions were changed so that the issue of primary versus secondary is irrelevant. The way it was, you had to have had that assumed knowledge in order to answer 1 or 2 of the questions correctly. But now you don't. It's irrelevant because it's talking about sexual characteristics. Were we provided any information with regards to uterine temperature, which is the answer choice A? And not to mention, one would expect the uterus to have a certain temperature throughout the organ. But nonetheless, we're not provided any information about that. And then answer choice B, location of the embryo with respect to the ovary. Well, the ovaries are here on top, and the unit actually says that the embryos were placed in a random way. And you could just look at the embryos, and there's no clear pattern that's being presented with respect to the ovary. In fact, the pattern is with respect to whether or not there's male or female on either side in terms of the eventual development of sexual characteristics. And then answer choice C was the levels of maternally produced hormones reaching the embryo. Again, there's nothing said about this. No information is provided, but there's actually a counterpoint that's provided. And that is that the development of secondary sexual characteristics or gender development to a degree is based on whether or not the embryo is beside one male, two male, or one female, or two female. So there's a relationship between the development of the embryo and its immediate environment without any discussion of maternal hormones. And so we're left with one is answer choice D, the levels of embryo produced hormones reaching adjacent embryos. We know it should be that because the first sentence of the unit is linking hormonal environment in the uterus affecting gender development. So, and then we see that if a female has two males, more masculine, one male, less masculine, zero, then more feminine than masculine. So we're able to determine that. So indeed, for one, the answer is D. And now, if there's any questions, please put it in the chat. And then for question number 2, of embryos 1, 2, 3, 4, 5. So we're looking at 1, 2, 3, 4, 5. How many are male? So we've already determined that 1, 2, 3 are male among these. And so for 2, the answer must be A. And then for 3, of the following embryos, which one will develop the most feminine features? Well, the most feminine features probably is going to be female in terms of the genotype. What's the DNA saying? And so we have our choices, embryo 2 and 4. Embryo 2 is male. Embryo 4 is male. Now, if you were going to compare a 1F male and a 2F male, okay, the 2F male would have more feminizing features. However, if you're going to compare male to female, well, then clearly the female would have more feminine features. So the other two to look at are embryos 9, answer choice C, and embryo 10, answer choice D. So 9 is female, but with one male near to it being influenced by this one male means that it would have more masculine features than a female that has no male adjacent to it. And so that's number 10. So number 10 has no males next to it. And so this would be the most feminine of the options. So we have, and then finally, in mice, sexual characteristics is determined by, so if we're talking about characteristics, this is just in a very general sense. That means it's including primary and secondary characteristics, and the gonads for the great majority of humans, XX would be female, XY would be male, and so that's going to be the genotype, so that we know that the genes are affecting gender. But the first sentence of this unit is the hormonal environment in the uterus affects gender development in mice. And so we know that it's an interaction between hormones and genotype, as these two things came to play throughout this unit. And that gives you the big picture. And just for your interest, question number 4 used to be, in mice, the primary sexual characteristics of an individual are determined by. And the answer was A, the genotype, because that's what is determining the gonads and the external genitalia. But ACER removed that feeling that is too much leaning on knowledge, and they would rather put you in some situations with puzzles and opposites. Okay, so that's rather straightforward, but also some strategy with regards to your scratch paper. Now we're going to move on to organic chemistry. We're going to do a few questions in organic chemistry. It's literally a few questions. It's going to be 3 questions, which means you'll have 6 minutes to complete them. So if we can get the link for that, and if you're watching on the video or YouTube later, you'll find the link in the description, and you can give a thumbs up or subscription if you like it. Okay, so it's going to be 3 questions from chapter 6. And why is chapter 6 particularly good? Because in this book with 14 chapters, 10% of the importance comes from chapter 6, which is alcohols. So we're going to be doing a unit that involves nomenclature as well as sort of pattern recognition, geometric reasoning kind of thing. So if you have some content to go through to look at in order to, you know, you can Google the answer or try anything you can to try to get to an answer if you can. But of course, if you haven't studied this material, then of course it's going to be very challenging. Okay, so this is questions 19, 21 from chapter 6. We're going to need a clock with 6 minutes. And please begin, and good luck. Okay, so let's go to question 19. And if you feel so inclined, you can put what you chose as your answer for question 19. And I'd like you, um, so yes, again, it's going to be helpful to use your scratch paper. And for organic chemistry, what's useful to do is to try to uh, put the molecules that you're drawing in the same format as what ACER presents to you. For example, this chemical reaction in a normal university course, they would never show you this on a test because this is one of many different types of reactions that some students memorize, but more so students sort of work out what's able to happen based on uh, nucleophiles and leaving groups. But for GAMSAT, none of that needs to be memorized. Which reagents will make a reaction become more likely to be nucleophilic substitution versus elimination, which is a normal thing to learn in undergraduate. It's not on the exam. Anything that's relevant will be presented in such a way that if a person with a science or a non-science background has a shot at finding the patterns. However, nomenclature, I mean, there's no way around it. Uh, you should know the basic systematic way to name organic chemicals for all the most common uh, molecules. For example, categories like obviously alkanes, alkenes, alcohols, and carboxylic acids and esters. And we are looking at esters here. Now, I have a separate video that you can look at that goes through nomenclature from beginning to end, but that's not what we're doing today. So we need to write out, well, for the question, it says represents the reaction between propyl ethanoate and one equivalent of 2-butyllithium. One equivalent means one. So here you see in the summary, two reacted of these compounds. But here in step one, we have one of these reacting. And so let's focus on this. And keep in mind that we're looking at propyl ethanoate and 2-butyllithium. So I'm going to draw propyl ethanoate like this. So first, I'm going to draw the ethanoate part. So it has to look like ethanoic acid. So I'm not going to write in the hydrogens, but I'll put C. Okay, so that's the ethanoate part. And for those of you who have done your preparation for organic chemistry, you will also recognize that this can be called acetate. So ethanoate or acetate. And ACER has used both expressions in the past. And they have 2 or 3 units that require being able to complete the nomenclature for esters because and that's not the question. The question is not, can you do the nomenclature for esters? It's just that they use the words for esters. And if you can't draw it, then, it's difficult to identify what's going to happen according to the rubric that they're providing to you. So this is ethanoate. And so it's propyl ethanoate. So we draw the propyl group on the other side. So that's how esters are named. You imagine the carboxylic acid first, so as if there's a hydrogen here. And then you change oic acid to OAte. So ethanoic acid becomes ethanoate. Acetic acid becomes acetate. And then you name the group that replaced the hydrogen. So this is propyl ethanoate. So the question is asking propyl ethanoate and one equivalent of 2-butyllithium. So plus 2-butyllithium. So butyl means 4 carbons, and it's 2-butyl. That means the lithium is on the second carbon. So there's 2-butyl lithium. Okay, so we're trying to see how these add to each other. So, and we're trying to get the information from this. So we're looking for the organic product. And notice that I drew it this way so that these groups are the same with the group that I've been given. So it makes it easier for me to notice that you see this OET. Well, let me get this over a little further. Okay, so you see this OET, which is here, that's representing this group here. And do you notice that this is removed from the organic chemical here? So this is going, this part is leaving. Now, of course, if you know the actual mechanism, it makes sense because you have this is not for people with non-science backgrounds, but you have the nucleophile coming in here, forming the carbon-carbon bond, and then the best leaving group has to go. So not great choices, but that's the best leaving group because these are carbon-carbon bonds and those aren't going to break. Okay, so we've identified this group as one going. Now we need to add something. Do you see how this CH3 group here came in and that represents this? And that represents this. So that's the CH3 group here. So now we have to plug in the group that is attached to either MgBr or lithium, because MgBr, which is a Grignard reagent, or lithium act in the same way. So now we have to plug this in. So I'm going to rewrite the carbon, oxygen. So I'm just rewriting this part left. Now we have to plug in this part. So I'm just going to plug it right in. Okay, so here's the mistake that some people might have made, is that they might have plugged it in at the end, but you have to plug it in to whatever it's connected to because this is the bond that's forming. So I'm just taking this whole thing and putting it here, and I'm drawing it in a way so that if I have time, half an hour, 45 minutes into the exam to come back and look at this is clear enough for me to understand what I was trying to do. And so please do keep that in mind as well. You want things to be as clear as possible so that you can revise your work if necessary. Okay, so I've got the molecule and now I'm just going to need to name it. And to name it, I see this is a ketone, so it's going to end in -one. I want the lowest number possible for where the carbonyl group is. So it's on the second carbon. And I have to count the longest chain of carbons. 1, 2, 3, 4, 5. This one's 1, 2, 3, 4. So this one's shorter. So 1, 2, 3, 4, 5. So this is going to be a pentanone, a 2-pentanone, or pentatwoone, if you prefer. And then there's this group here on the third carbon, 1, 2, 3. So it's a 3-methyl 2-pentanone or pentatwoone. And so that's 19B. Okay. And then looking at question number 20, given the mechanism provided in order to produce a secondary alcohol, which of the following must be true? Okay, so for those of you who are unfamiliar, whether it is primary, secondary, tertiary, it depends on the number of carbons that's connected to the central carbon. So here is the carbon. This is an alcohol, so it has an OH group. There's one carbon attached to it, so this is primary. And 2 carbons attached, secondary, 3 carbons attached, and that's a tertiary alcohol. Okay, there's a question. Aren't there 6 carbons making it a hexanone? Okay, so this is one of the rules of nomenclature, is that you look for the longest chain of carbons. That's how you know whether or not you use the prefix meth, prop, hex, oct, non. It's the longest chain, and a chain means in a row. So you have 1, 2, 3, 4, 5 carbons in a row. This is taking a detour. This is off the main chain. But you can test this carbon to see if it provides a longer chain. And you count 1, 2, 3, 4. You can't even count this way, because among the rules is you must include the most important functional group. The most important functional group here is not a carbon, because there's many of those, but is a carbon connected to the oxygen. So we're looking for chains that include this. And the longest chain is 5. So then it's a pentanone. Because what you were saying, to call this a hexanone, means this carbon is not here. The carbon is attached either here or here. That would be a hexanone. One would be a 2-hexanone, and the other one would be a 1, 2, 3-hexanone. But the carbon here is a side branch. And so we need to identify where this carbon is. It's on the 1, 2, 3rd carbon. It's a 3-methyl, and then pentanone. Okay, I hope that clears that up. Okay, now we're looking at this, primary, secondary, and tertiary. And so the implication here, keeping in mind that neutral carbon is going to bond 4 times. Neutral carbon is always bonding 4 times. So the implication here, if we see 2 bonds to the carbon, that means there must be 2 hydrogens, because the carbon must be bonded 4 times. If there are 3 bonds that we can see, that means there must be a hydrogen. Okay, so hydrogen is the most ubiquitous element in the universe. And so in organic chemistry, sometimes we don't actually write it out because it's implied. And then over here, we see 1, 2, 3, 4 bonds. Carbon is already maximally bonded, so there can be no hydrogen attached to that central carbon. Okay, so keeping in mind what primary, secondary, and tertiary is, and so if we want to have a secondary alcohol, here we go. This is the alcohol that is being produced in the summary. If we want a secondary alcohol, that means that there's going to be 2 carbons attached to the central carbon, 2 alkyl groups. Those are alkanes minus a hydrogen attached to this. Well, look, we have R and we have R. This implies that they are the same. And that means they're both alkyl groups as defined in the passage. Okay, identical alkyl groups. So these are alkyl groups, but we know that to be a secondary alcohol, you can only have 2 alkyl groups. That means R prime must be hydrogen. This has to be hydrogen. And no other requirement is necessary. Don't forget, we need 2 hydrocarbons, okay, carbons connected to this. And that's secondary alcohol. So this has to be hydrogen. Okay. So that means 20 is A. And then for the final one, which I'm sure presented some challenge for some of you. So the first step, again, is that remember how, ACER likes opposites, likes to turn things. Sometimes they'll draw the ester this way in the passage, but then all the answer choices will have the esters in the opposite direction, flipped on the side, to see if you recognize that, if you're following the bonds properly. So when you look at the alcohol that you are provided for this unit, notice that, just bring this down a bit. Notice that the OH group on the alcohol is oriented below, but in the mechanism that you provided, it is oriented above. So what I'm going to do, first, I'm going to count my carbons. Okay, so we have an OH group attached to a carbon. Then there's 1, 2, 3. OH group attached to a carbon, 1, 2, 3. Okay, so those 3 carbons were repeated. OH group attached to a carbon, 1, 2, 3, 4. Okay, so I'm going to redraw that so that it looks just like this. Okay, so we have the carbon, we have an OH group, and we said there was 1, 2, 3, and 1, 2, 3, and 1, 2, 3, 4. So now I've made it so that it looks like this. So now I can see that this is R, and this is R prime. So I hope everyone can see that, because once you see this, then you can look at what you must have started with, because I know R is propyl, so I know that it's going to be propyl lithium or propyl with the Grignard reagent, MgBr or whatever. So magnesium bromide. So, but it's going to start with propyl. And then I can look at the answer choices and I can see propyl lithium, answer choice A, and propyl magnesium bromide, answer choice D. So that means A and D are so far reasonable because it answers this first part. Okay, so now let's look at the ester. Keeping in mind R prime is these 4 carbons. So let's put that in there, right here. 1, 2, 3, 4 carbons. That's the R prime connected to carbonyl, oxygen, and there's an oxygen and R double prime. So I'm just taking what I've noticed here for the R prime, and I am plugging it in right here. And so I have this. So then what is this called? What's the name of this? Yes, you're mostly on the right track, yes. But if there was a hydrogen here, then we would call it pentanoic acid. But when it's an ester, we change the oic acid to O8. So this is called pentanoate. Okay, so this is pentanoate. So now I'm looking at answer choices A and D, and I see there's only one pentanoate, and that's answer choice D. So 21 is D. Now you might wonder, but 21 says hexyl pentanoate, which means there's 6 carbons here, hexyl pentanoate. Does that affect us? No, because the product only has R prime and R in it according to the information we're provided. So we're not given information as to what R double prime is. So the answer could have been hexyl, it could have been octanol, it could have been butyl, it could have been methyl. It's not relevant to the information that we're provided. We only are given the information about R and R prime and what could make it. And only answer choice D has both the correct propyl part, propyl lithium or propyl magnesium bromide, and it also has the proper ester part, which is the pentanoate. Okay, and there's a question. Could we have just counted the longest carbon chain as a way to get the answer as well? I'm not seeing how you would do that. Now, of course, you know, if you had to name this, you would be counting the longest chain, but I'm not sure, I'm not seeing how you would necessarily do that. But also, I do want to underline something, is that we're looking at, you know, nucleophilic acyl substitution. You don't have to memorize that. But on the exam, there's innumerable different mechanisms or reactions that ACER can present. And this is a strategy to try to draw your molecules to look in the same way that ACER has it so that you can identify what groups go where. And in question 20, could you please clarify why one of the R couldn't have been a hydrogen? Well, for question 20, if you're asking why one of these R's could be a hydrogen, but these R's are identical groups. So R must equal R. So for you to say one of the R's is, it's either R is hydrogen or R is not hydrogen. And if R is hydrogen, this can never be a secondary alcohol. The reason, by the way, you're putting a prime, R double prime, is to say that this alkyl group is different from the other alkyl groups. So if you see R prime multiple times, the assumption is that that R prime is always the same as the other R prime. The R prime is not mutating. Oh, I should also mention, this is the most common way that ACER will identify R's on the exam, but they have done this before as well. They have done like R1, R2, R3, and they've also done this one, R1, R2, R3. So just different ways to follow the same group. This one is frowned upon in organic chemistry courses because it has other implications, but this is common, and the R prime ones are also common. Sometimes with respect to oxygen, sometimes an asterisk is used so that you can follow the oxygen through the reaction. Okay, so in question 1, how did we get the pentanoate? So in question 21, the pentanoate, and so for the ester, we see that the ester has this R group and then the carbon. And the alcohol that we're given for yes. Okay, so here we have the R groups. Here we have R prime, and here we have OR double prime. And here's our R prime, which we identified as being these 4 carbons. Why do we know that? Because this R has to be the same as this R. These 3 carbons, the same as these 3 carbons. So we know that this has to be R. So what is the thing that was different from R? R prime. And so here's the R prime. So now we're going to take these 4 carbons, R prime, and we're going to plug it into C double bond O. take the 4 carbons, these 4 carbons being R prime, and we just plug it right into the C double bond O. And now we name it pentanoate. And by the way, sometimes, ACER can ask, what is the relationship with the ester to the R prime group? And you will see that the ester will always have 1 more carbon than the R prime group. R prime has 4, the ester will always have 5 because the R prime is connected to a carbon. And this whole thing makes the ester. So sometimes there's a question to see if you can see the forest from the trees. Now, if you haven't done your organic chemistry nomenclature, you should watch the video on that first, and then just keep practicing. Okay, so that's it for today. We'll do another combo in the next free online tutorial, in which we'll do 1 unit from ACER and then 1 unit from the gold standard GAMSAT Master Series. Okay, so that's it for today. I wish you good luck with your studies, and see you in the next one. Oh, any further questions, don't forget, you can always post in our forum, and I'll get to that. But right now we have another a 3-hour tutorial starting on section 1, formerly known as. So good luck with your studies, and see you in the next one. Bye for now.